We are starting with question number 26. Okay. Sine inverse of 6x plus sine inverse of 6 root 3x is equal to pi by 2. Okay. So sine inverse of 6 root 3x is equal to minus pi by 2. Sorry. So minus pi by 2 minus sine inverse of 6x. I'm taking this term on the right hand side. So sine inverse of 6 root 3x is equal to minus pi by 2 plus sine inverse of 6x. Take minus sign common. Okay. So sine inverse of 6 root 3x. The sign you take this sine inverse on the other side, it will become sine. Okay. So I'll do that right now. 6 root 3x is equal to sine minus pi by 2. I take this value as theta. Okay. Now sine of minus x, I'll apply that formula over here, is equal to minus sine x. So this is x. So this will be minus sine pi by 2 plus theta. So 6 root 3x minus sine inverse of minus sine of pi by 2 plus theta. Not inverse, sorry. Now pi by 2 is 90, 90 plus is anti-clockwise. So in this quadrant, your sign is positive. Okay, y-axis sign changes to cos theta. So 6 root 3x minus cos of theta. Now theta we had taken as sine inverse of 6x. So that I'm going to put over here sine inverse of 6x. Okay. Now convert the cos sine inverse to cos inverse. So this will be cos inverse of root 1 minus 6x the whole square. See, we have this formula. Sine inverse of x is equal to cos inverse of root 1 minus x square. Okay. But then we are having 6x. So this will be 6x the whole square. Fine. Now cos inverse and cos is getting cancelled. So 6 root 3x is equal to minus root 1 minus 36x square. Squaring both the sides, 6 root 3x the whole square, 1 minus 36x square. Minus square is positive and root is gone due to the square. So this will be 36 into 3. That is 108x square, 1 minus 36x square. Send this on the other side. 144x square is equal to 1. So x square is equal to 1 upon 144. X square is equal to x is equal to root of 1 upon 144. So x is equal to 1 upon 12 plus or minus. Now see guys, the angle on the right hand side is negative. Okay. So angle is negative over here. So if we put x value as positive over here, positive 1 by 2. So we'll get a positive answer over here. Okay. Because sine inverse of positive is positive only. So both the positives will give me a positive answer. But then if we put a negative answer, that is minus 1 by 2. Okay, so sine inverse of minus x in both the cases will be minus sine inverse x. Okay, so that will give you a negative answer. Positive with positive, it won't work. You will not get a negative angle on the right hand side. Fine. So you get a negative angle only when the x value is negative over here. Fine. So x cannot be positive in this case. So x is minus 1 by 12. Fine. Next problem, question number 27. Sine of cot inverse x plus 1 is equal to cos of tan inverse x. Now by triangle method, I'll convert this cot inverse into sine inverse. And by triangle method, I'll convert this tan inverse into cos inverse. So we'll do it one by one. So first, let us take this cot inverse of x plus 1. Let it be A. We are converting this into sine inverse because outside there is sine. Okay, we are converting this into sine inverse. Outside there is sine. So let this be A. So cot A is equal to x plus 1. Tan A will be the reciprocal of x plus 1, which is 1 upon x plus 1. This is the triangle. This is 1, this is x plus 1. So by Pythagoras theorem, this will be x plus 1 the whole square plus 1, which is equal to x square plus 2x plus 2. Okay. So sine A will be 1 upon root of x square plus 2x plus 2. Opposite upon hypotenuse. So A will be sine inverse of 1 upon root of x square plus 2x plus 2. So we converted cot inverse to sine inverse. So instead of cot inverse, I will write sine inverse 1 upon root of x square plus 2x plus 2. Okay. Now tan inverse we will convert to cos inverse. Fine. Tan inverse we will convert to cos inverse. That also using a triangle method. So let tan inverse x is equal to b. X is equal to tan b. Tan b is equal to x upon 1. So this is b. This is x and this is 1. So this will be root of 1 square plus x square. So it is 1 plus x square. Okay. So cos b 1 upon root of 1 plus x square adjacent upon hypotenuse. So b is equal to cos inverse of 1 upon root of 1 plus x square. So tan inverse is getting converted into cos inverse. So this will be cos inverse of 1 upon root of 1 plus x square. Now cancellations on both the sides, sine inverse and sine is getting cancelled, and cos inverse and cos is getting cancelled. So we are left with this. Now we'll square both the sides. So 1 upon x square plus 2x plus 2 is equal to 1 upon x square plus 1. Take reciprocals. X square is getting cancelled. Okay. 2x is equal to 1 minus 2, which is minus 1. X is equal to minus 1. That is your answer. Fine. Let us go to question number 30. Fine. So in question number 30, cos inverse of x by 2 plus cos inverse of y by 3 is equal to theta. And we need to prove something. That is 9x square minus 12xy cos theta plus 4y square is equal to 36 sin square theta. Apply formula cos inverse x plus cos inverse y over here. So cos inverse of x into y minus root of, you know that formula, right? Cos inverse of x plus cos inverse of y. So this is x and this is y. So that formula I'm applying. 1 minus x by 2 the whole square, 1 minus y by 3 the whole square. Okay, now send cos inverse on the other side, it will be cos theta. So xy by 6 minus root of 1 minus x square by 4, 1 minus y square by 9. Okay. So I xy by 6 minus combine the root. We can combine the root because between the roots there is multiplication. So whenever there is multiplication between the roots, we can combine the roots and take LCM also. Okay. So 4 minus x square upon 4, 9 minus y square upon 9. 4 minus x square upon 4, 9 minus y square upon 9. Okay. So xy by 6 minus cos theta. I'll isolate the root term. 4 minus x square, 9 minus y square upon 36. So xy minus 6 cos theta upon 6 is equal to 4 minus x square, 9 minus y square under root upon 6. Okay. So 6 and 6 will get cancelled on both the sides. Now to eliminate the root, we'll have to square both the sides. So xy minus 6 cos theta the whole square is equal to 4 minus x square, 9 minus y square. So a square plus b square minus 2ab. So 12xy cos theta, okay, equal to 36 minus 9y square minus 4y square minus 9x square plus x square y square. So you can see x square y square is getting cancelled on both the sides. Okay. Now what you do is you can take all the terms. This minus 4y square minus 9x square, you take it on the left hand side. So 9x square plus 4y square minus 12xy is equal to cos theta. And this term I'm taking on the right hand side. See why I'm taking this three terms together is because, once again, this three terms marked in green on the left hand side is because that is the LHS in the proof. Okay. That's why I'm keeping all these terms on the in the left hand side. So 36 minus 36 cos square theta. So 36 1 minus cos square theta, 36 common, 36 sin square theta. Okay. 9x square plus 4y square minus 12xy cos theta. And this also will be 9x square plus 4y square minus 12xy cos theta. This is your final answer. And this is as it is required. This is the final problem statement, what we were supposed to prove. Okay. So let us proceed with the next problem. This proof is over here. Let's go to question number 30. So we are supposed to prove cos inverse x plus cos inverse y. This is given, sorry, is equal to pi. Okay, and what we are supposed to prove? We are supposed to prove x square plus y square plus z square plus 2xyz is equal to 1. So cos inverse of x plus cos inverse of y is equal to pi minus cos inverse of z. Apply the formula over here. Cos inverse of x into y minus root of 1 minus x square root of 1 minus y square is equal to pi minus this. I'm taking it as theta. Okay. Now do one thing. Take cos inverse on the other side. Okay. So take cos inverse on the other side. So xy minus root of 1 minus x square, 1 minus y square is equal to cos of pi minus theta. Now pi is 180, 180 is over here, minus is anti-clockwise. Sorry, minus is clockwise, so it's over here. Okay. So cos pi minus theta. So in this quadrant, cos is negative and x-axis. Cos remains cos. So cos theta. So cos pi minus theta is minus cos theta. Xy minus root of, just multiply this, 1 minus y square minus x square plus x square y square. Okay, right? Now put the value of theta. We had taken theta for our simplicity. So theta is, let's go to previous slide and check what is theta. Theta is cos inverse z. So I'll write cos inverse z over here. Cos and cos inverse is getting cancelled. Now this minus z, I'll put it on the left hand side. So I'll write xy plus z, and the negative root, this is a negative root. Okay, I'll put it on the right hand side and make it positive. Root of 1 minus x square minus y square plus x square y square. Squaring both the sides to eliminate the root. So x square y square plus z square plus 2xyz is equal to 1 minus x square minus y square plus x square y square. X square y square is getting cancelled on both the sides. Take these two underlined terms on the left hand side and you will get the desired result. So this is your final problem statement. Okay, x square plus y square plus z square plus 2xyz is equal to 1. Fine. Okay. So in this manner, the entire exercise 4 is completed of ITF. Thank you.